In this final video in our unit on data analysis and statistics, we are going to look to choose the best model for some two variable data. So we have an example before us here that lists the average annual cost of attending a four-year private college. We're comparing to the first lesson where we looked at the UW public school universities. Anyways, we're going to use a graphing calculator to find a model for the data. Before we do that, I want to look at a couple of different things that you might run into. So as we choose the best model for data, one of the ways to do that is to make a scatter plot of your data points and then decide which kind of model fits it best. A couple of things we might run into. So for example, maybe our data points, look something like this, where they're not necessarily exactly clumped together, but as I look at that, I see, that looks to me pretty much like a straight line of sorts. So I would say, if I had to pick one, I would say that that's probably a linear model. Okay, looks like a straight line though. Again, you can excuse my goofy pen here. And if it's linear, y equals ax plus b would be the kind of equation that I would be looking for, where a is the slope and b is some constant, x being the independent variable. Maybe my data looks something like, I don't know, this, where it kind of has this trend where it heads up in the middle, but then it starts to head back down over time. Well, as I look at that, I see that my data has sort of a parabolic shape to it. If it has a parabolic shape to it, well, I'd say that would be a quadratic model would fit it the best. And then I'd be looking at y equals ax squared plus bx plus c, some quadratic model to give me a parabola. Could be upside down, could be right side up. Either way, that's a quadratic looking set of data. Another kind of model that we've used in the past was where our data, started slow but then grew over time, and then all of a sudden it took off. Well, if you remember, that kind of model was one that we called exponential. Took off in that direction. That would be exponential in nature. An exponential function looks something like this. Y equals a times b a base raised to the x power. X is in the exponent, therefore it's exponential. Now, we've worked with these three things in the past. We've found best fitting linear models, quadratic models, exponential models. The one we haven't worked with a lot is this idea right here, a times x to the b. I would call that a power model. A power model would be one that, you could technically say that a quadratic function is a power model, but a power model is going to happen when we've got a curve that maybe changes direction, once or twice or even, 3 times, something like that. I look at this is probably, 1, 2, 3 turns. That's probably actually a quartic model. So once we get into cubic, quartic, quintic, that kind of thing, anything above raising to the second power, we just call it a power model. Okay, so our calculator will figure out which model fits it the best if we were to choose power regression. Okay, that said, going back to my original problem, we're supposed to find a model for this set of data. Well, the first step for that is to always enter the data into your calculators by going to the Stat menu and then editing some lists. So I already got the numbers entered in list 1 and list 2. You might want to pause the video and do that right now. Now, one thing to note before you pause, list 1 I put down 1, 2, 3, 1 through 11, as in I took the first year in 01, 02, I took 01, then 2, 3, 4, etc. Okay, so match up the costs from there. Now, when you're ready, what we're going to do is we're going to make a scatter plot of our data. So to do that, we're going to hit second and then y equals. Takes us to the stat plot menu. Let's hit enter to turn on plot 1. So it brings it up to this menu. I'll hit enter once again to turn it on. As far as types are concerned, I picked the scatter plot, which is the first option listed here. X list is L1, Y list L2. That's good because that's my input values were in list 1 and my output values were in list 2. As far as a mark and a color, you can pick whatever you want. When I'm ready, hit graph. And at first, probably be disappointed to see something that's completely different. Here's a couple of graphs that don't match up with anything that I just typed in. So to fix that, I'm first going to go to the y equals menu and clear out any functions I've got there. Okay. Now, one thing to note as I'm clearing these out, see how plot 1 is highlighted? That means it's turned on. Later on, as you use your calculator, if you try to graph something and you get a message about error invalid dim, that means invalid dimensions, it means you need to turn off your scatter plots. Okay, normally these should not be highlighted. To turn them off, you hit the up arrow to highlight them and then hit enter. It'll turn it off nice and easy. Now we leave it on though. Okay, now the other thing I'm going to do is I need to find my data points. To do that, I hit the zoom button And normally Z standard takes us to the standard viewing window. Well, I want to see my statistics. Zoom stat. Look at this. Hit number 9. Zoom stat shows me my statistics in a wonderful window that makes them fit. How awesome is that? Now, looking at the scatter plot. Part of doing these problems right is picking out the correct model. Well, what does this look like? To me, it looks like it's fairly straight line. So I'd say that from my scatter plot, this is a linear model that would match this data the best. So if it's a linear model that matches it the best, we'll quit and go back now to stat edit, not stat edit, excuse me, stat calc this time. We're going to find the linear regression. AX plus B is the one we want, that very first one. Now, the X list is list 1. I need to change that. The Y list is list 2. That's great. For frequency list, I'll leave it blank. Now, for this one, this is a little neat thing. Store reg EQ. I'm going to store my regression equation as function Y1. To do that, alpha, F4, pops up my Y variables menu. Choose Y1. Now, what that's going to do is it's going to take the equation, whatever it comes up with, and store it in the Y equals menu so that it's going to graph the line right through the data points. It'll look pretty neat. When I'm ready, I hit enter to calculate, and it spits out some numbers here. Okay. Now here's what this would look like as I show you how to make that work in your answer. All right, so as I move it in here, here's the answer I'd write down. I would write down, not using the crazy pen. Let's just use a regular pen. Y equals A, which in this case is 456. We'll round it to 13, 456.13 times X plus B, the Y-intercept in this case is 29,107. Give it as the initial value back in 2001. 29,107.2, we'll round it to 24 cents, let's say. Now, kind of ugly, but there's a model. This is a model for the data. It fits it the best. Now, if I want to know how well it fits, I go back to my calculator, I hit graph, and my data points now have a line going through the middle. It's a pretty good deal. I got a best fitting equation, a linear equation at that. Fits real nice with my set of data.